Okay, so this is 5.4, the Pythagorean Theorem. We've probably seen this before, but let's talk about some things about it. Okay, so the altitude drawn to the hypotenuse of a right triangle separates the right triangle into two right triangles that are similar to each other and the original right triangle. So if I draw the altitude, it goes straight down and it makes right angle down here. We'll call that point D. So this tells me that this triangle here, ADB, is similar to CDB and ABC. Okay, so all of them are similar to each other. So we can write ADB, so triangle ADB is similar to triangle CDB, which is also similar to triangle ABC. Okay, the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the parts of the hypotenuse. So this tells me, right, think about geometric mean. That tells me A over B is equal to B over C. So if I look at this, okay, so the length of the altitude, so that's this guy right in here, okay? So I would have AD, which is this guy, over BD. All right, we can put those little lines on top. Have to be equal to BD, remember geometric mean, over, so AD to BD is BD to DC. All right. Okay, the length of each leg of a right triangle is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to that leg. So that's telling me that AC, which is the hypotenuse of this big triangle, see that's right here, is to the hypotenuse of the little triangle, which is right here, AB. So we know that we're going to have AC to AB, right? We have hypotenuse to hypotenuse as AB, which is the leg, is to AD. Okay, so we have hypotenuse to hypotenuse as leg is to leg. Now here's the Pythagorean theorem that we all know. The square of the length of the hypotenuse of a right triangle is equal to the sum of the squares of the legs. So that tells me that a squared plus b squared has to equal c squared. So this is the one that you definitely want to remember. Now, the opposite of that is just this. This is saying if A, B, and C are the lengths of the three sides of a triangle, and C is the length of the longest side, and this is true, then it's going to be a right triangle. So let's try this out. So let's see. The longest side here is 13. So 5 squared plus 12 squared. Does that equal, I don't know, that's why I put a question mark, 13 squared. Well, 25 plus 144. Does that equal 169? Well, yes, 169 equals 169. So that tells me, if we read this, with the right angle opposite the side with length C. So that tells me that this guy is the right angle. So yes, right triangle with, well, we wanted to label this ABC with angle A equal to 90 degrees. Remember the measure of angle A. Okay, let's try this other one. Why don't you go ahead and pause it and see if you can figure it out. All right, so this is the longest side, so we need to see if these two add up to that one. So 9 squared plus 7 squared, does that equal 10 squared? Well, 81 plus 49, does that equal 100? Well, 130 does not equal 130, so no, not right triangle. Okay, here are some Pythagorean triples. A Pythagorean triple is a set of three natural numbers of ABC such that the Pythagorean theorem is true. These are used less frequently, but they're still important to write in our notes. Frequently. These are important. Now, if we look here, we have 3, 4, 5, 6, 8, 10, 9, 12, 15. They don't really change. This one here, I just take 3, 4, 5 and multiply all of them by 2. This one I'm multiplying by 3, and so forth. You could multiply by 4, 5, 6, 7, and so on. 5, 12, 13, that's another popular one. You multiply by 2, and that gets us 10, 24, 26. Another one, 8, 15, 17, we multiply by 2, 16, 30, 34, etc. You can also do the same here, and you can figure out what those are as well. So these are important. Make sure that you have these in your notes. Okay, let A, B, and C represents the lengths of the three sides of a triangle with C as the longest side. Now this helps us figure out if the triangle is obtuse or if it's acute. If I find out that C squared is greater than A squared plus B squared, well, that tells me it's an obtuse triangle and the obtuse angle is opposite the longest side. If it's less than A squared plus B squared, then it's going to be acute, and that means that all of the angles are going to be acute. Okay, we're not going to have any right angles or any obtuse angles. So let's do some examples. So I have a triangle ABC, and I have one side extended to D. So I know that 4, 7, and 5 are my side lengths. So let's find out. If I go ahead and do this, I'm going to see, all right, C equals 7. Is 7 squared less than 4 squared plus 5 squared? Well, let's see, 49, is that less than 16 plus 25? Well, 49, is that less than 41? No, it's actually greater than 41. So that tells me that this angle in here is actually obtuse. It doesn't look like it, but it is. Now, if this angle is obtuse, what does that mean this angle is? That has to be acute. Okay? Let's look at this other one. Is 8 squared, we'll say greater than, 6 squared plus 7 squared? Well, 64, is that greater than 36 plus 49? Well, 64, is that greater than 85? Nope. 64 is actually less than 85. So that tells me that this guy, HFG, is actually acute, with this guy out here being obtuse. Okay?